Nem que seja para você depois exporem lá no schematics.
Mas obrigado a vir para aqui, hein?
Já vai ser edição.
Não me engano. Hi. Can you hear me? Okay. So let's start. Okay, so welcome to another DevOps Business session. And I'm going to start with a small intro, like we always do, and then we're going to go to the talks, and then we can do the social part after. So here is the usual contact points for sending emails or following up the YouTube channel. We publish all the videos. We are now starting to experiment with streaming, and then we're going to publish in the same channel. So you can see all the history from since the beginning. So I need to first start by welcome or thank you to our sponsors, OutSystems, Besides, ShiftLab, Fiercely, Lardud, Mercedes-Benz, and Bible, and Int. And then silver sponsors, equally experts. We need to thank you all for the venue, for the food and drinks after. So without them, this will not be possible. So thank you very much. Very important call for talks. We are always looking for teams and speakers, and we depend on you guys to submit your ideas. Okay, so send your ideas, your proposals. We really need them. It's becoming harder and harder to get teams, and so that's why we also with frequency of this. We're doing this every month, and now we are doing once every quarter. So please, if you have a story to tell, if you know anyone that has a story to tell from your work, any friend, anyone, just submit it. So today is the 62 meetup, the third for this year, and it's about unlocking cloud potential. We're going to have two stories about dual dive in Kubernetes self-packaging and dynamic cloud strategies. First talk going to be by Gustavo, dynamic cloud strategy from conception to implementation and beyond. Gustavo Gama is currently Carlsberg, at Carlsberg Cloud Center of Excellence, the lead cloud architect. Second one going to be by Daniel Pequena from iFood, building your own Kubernetes distribution. Very important, you are receiving a ticket, we're going to do a book raffle. Since the speakers already have the book, we have 3 to give, okay? So 3 of you are going to have, can take this book home. So don't go away before the book raffle at least. And after we have food and drinks, okay? Again, thanks to LCs, and I hope you can talk with the speakers and enjoy it. Okay. So let's start it, and Gustavo first, which is this one.
Nice to meet you all. Thank you for coming, and I hope that I can get out here fast so Daniel can come in and say the technical part, because this one is more of an idea on how to build the cloud strategy and how to make it dynamic, because the world is dynamic. So my name is Gustavo. I have some years on the cloud already. So I work with small, big, whatever they need, and try to bring them to the cloud the best way possible, since this is a very, very demanding perspective. Small, if you want to talk to me, please be aware, have one. Why do we need a cloud strategy? So cloud nowadays is fundamental. It's the way that most of the companies are going through. It's not only a trend, but it's also bring us a lot of capacity. But the most important thing is that the business, the world, is very uncertain. So we need to be dynamic on our changes so we can build a better performance and not go through the cost challenge that this brings. Cloud is a very expensive renting system. So let's see if we can build something that can give us the idea of how to adapt ourselves. The other thing that's quite important is that technology is changing at a speed that is very, very fast now. Last time we had a very big challenge. We take like 100 years with the Industrial Revolution. Then we take like 50 years with Google and Microsoft. And now we take like 6 months with OpenAI. So the speed is completely astonishing. So why do we need this? Because we need to have some kind of guidance on our way of working in the cloud. And the strategy can be your guidance. And why it's dynamic? It's dynamic because we cannot have a static thing since the world is changing, since the technology is changing. So we need to have a strategy that can spread out to any kind of technology that comes in without breaking the old ones that we already have implemented. What do we need the cloud strategy? Overall guidance, of course, but we also need to bring in the team organization, the skills, the correct skills. One thing that technology speed makes us is that the capacity to bring in people with skills is very, very difficult to accomplish because of the technology being so fast changing. So this cloud strategy also brings up the idea how many skills do we need and what kind of mindset do we need also to bring in. These topics are very important. We also need to guarantee that we have people in-house that can support us, and if we don't have enough, we need to hire them fast in a very convenient way. And then nothing can do without having some kind of metrics to see our success. And the cloud strategy is going to be one point that gives you metrics to accomplish the measure that you need. Personally, I think that these 6 topics, like checkpoints mode, we can deliver us a good cloud strategy. One small detail here. If you have a no-go in one of it, probably we need to rethink the cloud strategy for us. The first checkpoint that I think it's quite important is to align what are the goals in the company objectives so we can do the best delivery to them. If we don't do this, we are going to bring up a very, very nice machinery, but no one can handle it. So it doesn't make sense. So this alignment must be done somehow by establishing what kind of cloud we need effectively. Nowadays, there are a lot of clouds. And when I say a lot of clouds, because they are, I can almost make a song with this. Okay? Multi-cloud, poly-cloud, hybrid cloud, private clouds. Come on, this is a lot of technology that comes in. And once you have this clearly defined, what kind of technology are you going to build in, we can now make a way to guarantee that our business cases, our use cases, can have a clear vision how to be implemented. And that's one point of dynamic that we need to put in. The second part that is here is the enterprise landing zone. So enterprise landing zone is a well-architected multi-account system that can allow us to apply governance and security in the same way to every single use case. And that point gives us a capacity, or at least the trust, that when we go to and deploy a workload in the cloud, we are able to guarantee that we comply with all the rules, business, company, and technology that are needed to guarantee that we have success. One other topic here with the enterprise landing zones is that once we decide what kind of zone we are going to deliver to the small case, then everything is already in place. So we don't need to rethink every time we bring a new workload to the cloud. And that's quite important, because every time we rethink, we do a different thing. So if you follow the different thing every time you do, after a couple of workloads, you have a huge amount of tech that available to call in. There is no other chance for us that cannot go through these two topics, the governance and the security. Governance is compliance rules. So this is something that the business have to give us as a way to bring up the business itself in a correct way. The same thing applies to security, because the cloud is very exposed. So there's no other way. The cloud by nature is exposed. So we need to guarantee that from bottom up, all the security measures are put in place, so you have a good foundation when you bring up workloads. But both of it have two topics that are very important. One, must be auditable. So it's important that you have a way to guarantee to see who did, who accessed, why did access, every point. And the other one is there are so many rules that you need to put up that you need to prioritize. It's almost impossible to put them all up. So make it clear what are the biggest important ones and prioritize that, and then let the other ones go as possible to put in place. It's impossible to go 100%, so don't try. I tried, it doesn't work. The other point that goes here with us is that if you don't mobilize the entire company to go to this kind of mindset, you are going to have a huge amount of obstacles to overcome. So the point is, let's bring in the teams, let's empower the teams to do things, and more important, let's bring them a clear vision of the strategy that you want. Because most of the time, I have, for my own experience, that teams doesn't know what is being done, why it's being done, and most importantly, most of the time they even don't know the strategy of their own company. So this is a point where I touch a lot of time, mobilize the teams so you can have allies in your journey. We talk about migrations, and this migration is very important to clarify. There are a lot of migrations. I'm not only talking about on-prem to cloud. I'm not talking about, I need to talk about lift and shift. I need to talk about application modernization. I need to talk about monolith to microservices migrations. All those must be covered by the plan. There are use cases that you have that you need to put up as a way to mobilize the teams to know what they have to do, and most important, to give the company the chance to survive, because now it's survivance that we are talking about. If you don't go to the digital fast, you don't survive in our world. It's a matter of time. So when we talk about migrations, the plan is quite simple. You have to put it up, the use cases of what migrations you have to do, and once you receive the requirement for a workload, you go to the plan, you go to the cloud strategy and take, this is the case, so I apply this model. Don't think, apply. This topic is very, very dear to me, okay? Get sponsorship. If you don't get sponsorship, don't even try it, okay? I know that most companies have big structures or small structures. In a big structure, you need to go up to the top. If you don't go up to the top, most of the other ones will not care about you. So get the sponsorship. You need funding, so you need to go to the CFO. You need supporting for empowering the teams, CIO. You need security and governance, CISO. And then you need someone to put up the things in blueprinting or in implementing, so center of excellence. I know that small companies don't have all this, but in small companies it's easier because you need only basically to talk one, the owner. And if the owner say, let's go, most of the other teams will go without questioning. In a big organization, that doesn't happen. Okay? So go to the top. That's the only way you can implement something like this. Adopting the cloud, it's not an easy journey, but it's very, very important. The fourth topic is design action plan. So this is how you put up all your use cases and what is the solution for each use cases to deploy the workloads. But you have a couple of challenges here. Knowing the landscape of your organization is a challenge. I work with a couple of big companies, and to understand what they already are using is a huge challenge. Okay? They have hundreds and hundreds of applications deployed, and no one knows why they are deployed, by whom they were deployed, and who's maintaining those applications. So it's a challenge. First thing, assessment. Don't even think about it, assessment. Give me all the applications. I need to know where I'm going to put up my money. The second thing is the cloud native mindset. Okay? Why cloud native? If you go to the cloud, why do you bring the old stuff? Okay? Maintain yourself in the cloud. And this is going to make us clearly vision when we talk about IaaS, SaaS, PaaS, serverless, containers. There's a lot of architectures possible nowadays. So as long as you maintain the cloud native mindset, that's the only way you can take the full benefit of the cloud. If you don't have this in-house, hire. Don't worry, hire. The third one, cloud first. If you are going to the cloud, please maintain your cloud first mindset. Don't let applications to go to old ways of working like on-prem or hybrid or whatever. This is the only way you can bring in the cloud. If you have an exception here, you are going to bring new tech debt to this. Maturity. I will show a little bit further a slide of maturity. Maturity is the state where your organization is in terms of adoption cloud. What we need, and once we reach the slide, we will understand, what we need is at least to get to the DevOps mode, but if possible, to the platform team mode. Network and security, these are nightmares, completely nightmares. They are so complex, they have a lot of hidden tricks, and the only way to bring this is to try to bring from ground up a very simple solution where you can flexibilize the new features that are required. If you go and on top of what is already there, you're going to have a lot of headaches on the process. And communication. This is a very important one. If you don't communicate with everyone, no one knows what you're doing. This is going to be another obstacle that you have to overcome. So go to newsletters, do demos regularly, put up the information that you put internally to your team, take it out. Even if people doesn't understand completely what you are saying, at least they are aware that you are doing something. So it's easier to put your work in place. I talked a little bit earlier from maturity. There are a lot of ways to calculate, to classify the maturity of a company. I'm using this one because this is quite simple, 4 levels. Most of the companies nowadays, I think they pull here between 1 and 2. There are a lot of zeros out there. And our goal is to go to 3. So this is basically what I could give up in terms of maturity for the company, where you do everything by self-service, where you have external processes, you have complete transparency, API-based, everything is there. This one I'm going to skip, only referring to things. Again, cloud first, native, PaaS and SaaS, and lift and shift, please, last resource. If you don't do this, you're going to suffer to bring the lift and shift into the cloud afterwards, okay? The rest is everyone already understands the point. So once you have these use cases already established, where you're going to put the workloads, what is the difference between the landing zones that you're going to use and what kind of rules do you follow, we ended up we need to classify all workloads that we have. So if we have a IaaS PaaS solution, we have a container solution or serverless solution, these have already ways of working that we need to classify. This is a way to minimize the risks, minimize the impact of the stack, and most important, to not lose control of the dependencies. One other point that this gives you is the teams. Who's the teams that are going to support this? And identify who's responsible for supporting the workloads that you bring. The process of migration that we talked a little bit earlier is taken here by giving them priority based on cost and benefit. I know this is going to be not very well received by everyone, but it is, in fact, a good way to put up advantage on the journey to the cloud. If you have a benefit with cost, low cost, it's easier to explain, it's easier to implement. If you have a lot of cost and don't have any benefit only because someone is forcing you to do that, it's not a good way to go. Please maintain this. And once again, lift and shift is last resource. This is a nightmare. I can give you a couple of examples of lift and shift of more than 1,000 machines, and it's a nightmare. I'm going to take back again to the problem of the skills and mindset, because we need to hire most of the times. Technology is recent, so we need to have people with knowledge. It's not easy to find. But since it's not easy to find, training our internal is very important. Give internally the capacity to grow and to use the technology the right way, it's very important. And once you have internal enough or not internal enough, you go and do contracts for specific tasks that you don't need them to maintain afterwards. So adopt the cloud first mindset is quite important, and that's the only way you can bring it up. It's to put up people with training on the topics. Establish governance. This one must be done on the first migration. If you migrate anything, any workload, the first thing you do is establish the governance and responsibility. Who's owners? Who policies do we need to follow? What is the monitoring that we have for that workload? And one point, if we are going to multi-cloud or polycloud, we need to deploy a third-party tool that can correlate, that can take up the risk management and can take the threat visibility. Because you are going to use 2 different providers working together. If you don't have this, you cannot even understand what's happening to you in the process. The other part is that the responsibility. I like this one because this is simple, okay? So if we go from top to bottom, product team and dev team should know what kind of segregation they need in their own application. That's not a platform responsibility. But the platform responsibility comes to the implementation and automation of the process. And this is very, very important. we need to go infrastructure as code. We need to go infrastructure from code, if possible. We need to have everything like configuration completely declarable. If not, it's going to be. Security team must have our back in the internet and web exposition. That's not a job from platform. They only do the work. They are not responsible for it. So security team must come in. And network team, unless they have capabilities in the cloud, I found a lot of companies that do not have. The network team doesn't know how to work in the cloud. The networks are different in both worlds. So, but they know how to do network. And so the platform team again comes back and supports the network team in implementing the network side. And please don't start without a tool chain. Please, why? Easy. If you start without a tool chain, every team will have their own tool chain. And then you have like 200 applications to support in your CI/CDs, in your testing environments, in your staging environments. It's a mess. You have like 20 applications that do documentation nowadays. It's Confluence, Notion. I don't know how many. It's a lot of them. If you don't specify your tool chain, you're going to, basically, it's going to be very hard to maintain your journey to the cloud. The rest, everyone knows. No need. And we reach out to the last step, optimize and scale. So in the optimize and scale, we found out that a B model is quite useful for us, where you have the center of excellence responsible for putting up the governance, the brokerage, and the maintenance of the system. You have the development teams scaling up their own applications through containers for serverless, whatever they need. But both sides need to come up to a community practice. This is the only way you can share the knowledge that you're going to receive every time you do workloads. And this will give you a capacity to do this nice word that I like very, very much. Blueprint sharing. Because it is the way you can save time. Every time you save time, you gain time to study, to put up new technologies, to put up new applications. The only way is saving time. To save time, you need to do what is already tested, and it works for the company without breaking anything else. So, takeaways for the organization. Well, first, declarative mode, level 3 from our maturity. Modernize all the applications. And start by small applications and see how fast you can go. Then you can scale to bigger applications. For the side, for the team level, this one is also a good one. You bring it, you run it. Okay? So if you need to bring something new, you buy something new, you know that you have to run it. So you have to have the knowledge to run it and to maintain it. That's not going to be something that you can spare to the platform team because there's no other chance. Platform teams are very small. The other one is you have to evolve, the platform have to evolve with new business cases or use cases. But it cannot break because some project has a specific thing that changes the platform. So you need to adapt the project, not the platform. You need to evolve the platform to support the project. And one thing, it seems to be quite good if we are able to put an application or a domain. When we call domains, we call knowledge domains, like customers, like sales, like the domains that are not URL domains, okay? Per landing zone. This will give you the capacity to segregate the workloads and put up specific rules for each one. And this is quite important when we have governance and security on top of this. For 20 minutes on this dynamics, it's quite fast. So if anyone has questions, please be happy. If not, if you want to make the questions afterwards, you have my contacts here and see. Thank you very much.
So, anyone has questions? You can always talk after, but we have 5 minutes questions now if you want. Okay.
Hello.
Hello.
Okay.
size, we're talking about maturity levels, and on the next one, we're talking about just thinking about not losing sight of dependencies. I'm wondering how do you do that in your case, because you come to the platform being application.
How do I do not lose dependencies on the platform side? Let's see in what context are you working. If you are a developer team, there is a way to find all the dependencies that your application uses. If we are an application, already a black box application, the vendor should give you all the dependencies that they use. That's clear. If we create our own dependencies, when we create our plan, our cloud strategy, we have already them explicitly done. Because when we talked about the landscape of the organizations, that's the point where we get the dependencies, basically. There are a couple of applications out there that raises all these dependencies in terms of the landscape, how many applications we have, what dependencies they have, if they have network dependencies, storage dependencies, API dependencies, other SaaS dependencies. So that's the way you collect them. Why do you need that? Because every time you have some troubleshooting to do, that's the only way you can understand what the impact that troubleshooting, the problem that you have to troubleshoot is giving you the reason for it. Did I answer your question?
Yeah.
Do you have any comments on cloud repatriation? So it seems there's been a lot of talk recently about doing the cloud and taking stuff back to in-house. And do you have any thoughts on that?
Couple of thoughts on that. I understand that, like I said in the beginning, the cloud is an expensive renting system. Okay, if you don't do it correctly, if you don't apply the correct components of the cloud, you're going to have a huge expense in the middle. Everything in the cloud, at least, I'm going to talk a little bit more AWS to simplify the process. Everything that is related with pricing in AWS has more than one variable. You pay for, in EC2, you pay for CPU and memory. In serverless, you pay for time and memory. In storage, you pay for time and space. So there is always more than one variable to put up. So the costs that you have in the cloud can be expensive, and we are not even talking about egress, okay? If we are talking about egress, that's going to be another talk, a completely entire talk to it. But there are products that probably are easier and cheaper to maintain in on-prem, okay? But on the other hand, it's very hard to someone to explain how much effort they put in the data center maintenance, people for the data center, how much time they use to guarantee that they have the same capability of an API-based deployment like you have in the cloud, or anything related with not having to buy the part of procurement of all the hardware that you need is so big nowadays and so extensive in time. I can give you an example. Before COVID, we could have a server in less than a month. After COVID, it took like 18 months to have a server. So all that have costs to the company. If you have capacity to calculate that ROI, then I can say, okay, probably it's cheaper to go back to the on-prem. But it's very hard to calculate this. So I'm guessing that for some companies, that can be an option or something, but for most of the companies that doesn't have those kind of resources, probably the cloud is a little bit more an option because of the scalability.
So we have time for one more question. Anyone?
Hello.
Hello.
Which CI/CD system are you using?
Sorry, could you?
CI/CD Jenkins, or what are you using?
Okay, that's a trick question. That's why we talked about the tool chain. Okay, so I can give you my personal taste. I cannot tell you what's the best or what's the worst one. It depends mostly on what kind of workloads are you talking about. If we have a Kubernetes system, probably we would like to listen about Argo CD. But if you have a development team and you are having product teams developing and putting up, so your DevOps mode, you probably would like to use something like GitHub Actions or GitLab CI, because those are simple, completely integrated and easy to configure. I'm personally, and I don't have nothing against Jenkins, but I still think Jenkins is still a little bit complex. You have to know Groovy to program that thing. It's another tool, another language that you need. And I know they have a huge amount of plugins over there. Most of them do not have any more support. So you rapidly start to give your own support to those plugins. So it is whatever choice, but knowing this fact, I would say, depending on your workload, if it's Kubernetes, Argo CD seems to be a good choice. If it is development, DevOps, DevOps on the real sense of it, probably GitLab or GitLab Actions would be a good fit.
Okay, so thank you very much, Gustavo. So then I encourage you all to have some conversations after, and we can continue. So we will now take the second call. This is the first slide, right? Okay, for it's yours.
Hello. Hello. Okay, it's fine. Well, thank you all for being here. This talk is called Creating a Kubernetes Distribution. I have to give you a warning. I'm going to give this talk in English. However, this is my first talk in English outside of my of work. So if I encounter any language barrier, I will quickly switch to Portuguese. And if this is still a problem, I will switch to Italian. Not the language, but the thing that they do with your hands. So what I'm trying to say is that we will be able to communicate. I hope so. So, wow, I already skipped a lot. Okay, so this is my statement about this presentation. So by the end of this presentation, I hope you will know one more way to manage Kubernetes application setups in a standardizing and repeatable and scalable way. I usually don't put code on slides. I couldn't not put code in these slides. So if you want to point your cameras to this QR code, this will take you to SlideShare, and you can see the code on your own device if it's too hard to see on the screen. But I know that they have extra TVs here, so I think it will be okay. I'll give you a few more seconds. Okay, so here's our agenda. I'm going to keep reading this. I'm Daniel Pequena. My current titles are Dad and Husband. Those are the main ones, but I also have a bachelor degree in computer science and master degree in computer engineering. 20 plus years of experience in IT, occasional speaker. I am currently working as a SRE at iFood. I will explain what iFood is in the next slide. My main focus today at my job is Kubernetes and Service Mesh. I've been here in Lisbon for 2.5 years. So what is iFood? iFood is a food tech company based in Brazil. You can think of it as Uber Eats or Glovo or anything like that. We have around 5,300 employees, 2,000 tech people. That includes the DevOps team, the developer team, and so on. We process more than 70 billion orders per month. And that's translated to a lot of requests in our load balancers, and have more than 3,000 microservices to run our operation. Our Kubernetes number are, we have 98% of our workloads of those 33,000 services running in Kubernetes, and we self-manage more than 53 clusters, Kubernetes clusters. I have to do some acknowledgements. I'm only showing the result of a very long and extensive project, so those are the people that achieved this with me. Feel free to contact them. They are much smarter than me. And I have their authorization to put their names over here, so it's fine. So I'll just set the vocabulary here. So most of people, when hear Kubernetes distribution in their head, think about EKS or GKS and so on. This is not what I'm talking about here. We use K8s, by the way, to provision our Kubernetes clusters, sorry. But when I mean distribution here, I mean a way to standardize, setup, and customizations of packages, a test set of software packages that, when installed, provide all or almost all the functionalities that you need. That's what I mean by the Kubernetes distribution that we created here. So our problems start in 2018 when we started to do Kubernetes as our main, well, we started to play around with Kubernetes. It was around the middle of 2018. It was a very small setup, like 4 clusters, few apps, only a few tools to run those clusters. Our environment used to look like this, very simple. I mean, just one AWS account with the development cluster there and the other business units clusters. But that's in the middle of 2018, right? So by the September of 2019, we already had 11 clusters, and almost 20% of our applications were running on Kubernetes. We had dozens of tools to run those clusters. And what I mean by those dozens of tools, I'm talking about this kind of tools. I mean, we even call it machinery apps, that there are tools that you have to install in your Kubernetes clusters in order to make it scalable, to handle your logs and monitoring and so on. So I'm not talking about how we deploy our applications inside of the Kubernetes. This is not what this talking about. I will talk how we managed to set up more than 40 applications in a more standardized way. So how we used to do it, it was a very rudimentary way. We had a Git repository with a whole bunch of scripts. So if an operator just had to finish installing a new Kubernetes cluster, he would use kubectl to switch to that new context and run those scripts in order. That was a mess. It was not scalable. We even tried to automate most of it with Jenkins. That was our tool at the time. It's not anymore. But even though we still have a lot of problems, how to manage values on those scripts. But those scripts were not standardized. So some of them would use Helm2 by the time to install an application. Others will apply a whole bunch of YAML files. So there was no standard here. So it was very hard to reconcile. What if someone changed, I don't know, maybe the amount of memory that an application needed in production? How can you do this reconcile, get back to the Git repository? It was very, very hard. So we had a whole bunch of problems. And to make things worse, I mean, the cloud team told us, well, this is not the model of AWS account that we want to use anymore. So we'll have one account per business unit per environment. So that basically set on fire all of our plans on how to manage that amount of Kubernetes clusters. So we knew by the time that this was not going to be fine, and it didn't. So we had to declare the way that we were setting up our clusters as a failed project. It was, done. We couldn't handle that amount of cluster using this, and we had to come back to the whiteboard. So we set our requirements. So we started with, we want to be 100% Helm based. So this was one of our strongest premise over here, right? Our requirements. It had to be standardized, as simple as possible, flexible, extensible, testable, Git flow oriented, because it was the other way to do it. It was not. It wasn't. And like I said, scalable. Some of those words may sound really, simple, but I will try to build the concept of each one of those requirements throughout the presentation. So our source of inspiration was Linux distributions. They have a lot of strengths that we enjoy, and we wanted to be inspired by it. I'm not going one by one, but most distros have package management, and we wanted ours to be Helm. We want to have tests and life cycles, and one of the characteristics that we wanted to achieve was to be extensible. So a distribution is very extensible. I mean, if you are setting up Debian and you want to install third-party software, you just download the Debian package and install it in your server or in your machine. So we wanted those kind of characteristics in our new way to provision the applications. So I'm going to give you a schematics of what our distribution looks like, just to make it more concrete. So our distribution had to be just a set of Helm packages that together will provide all the features that we needed to declare a Kubernetes cluster production ready. Not only the packages, but the default values for each one of those. So by the time that we install this distribution inside a Kubernetes cluster, we could deploy our application just in the next second, and it could run and, like I said, be production ready. So this is sort of how it works. I will explain technically in a few slides later, but what you need to do is point your cluster to the distribution and run a couple of commands, and the result will be like this. You have your cluster with those packages. If you need to customize something, and you want, for example, more space or more memory in one of those packages, you can declare that in a way that I will explain later in your cluster. And when you run our automation, what you have is those new values inside the packages. We wanted this to be so well designed so it could, like I said, create a standard. Why? Because we didn't want to be solely responsible for installing Kubernetes clusters or Kubernetes packages and software. Remember, I don't mean our microservices, but we have a lot of other business units and teams that need to install tooling inside Kubernetes. For example, the security team and the Ingress team and the database administration team, they all want to do this. So who is better to define what are the best values or what are the best packages? We didn't want this to be centralized on us. Okay, so if you want to build that, you have to choose your tools, right? So at the time, we looked into a whole bunch of tools that we could use. Remember, this was around the end of 2019, and we ended up using Helmfile. Does anybody know Helmfile here? 1, 2, 3, 4, 5. Okay, it's better. So for those who doesn't know, Helmfile, in a very short way, is a wrapper around Helm with steroids. I mean, you can imagine a Helmfile as a Helm chart of Helm charts. So there is some characteristics that were very nice to our goal. For example, you can, Helm files are composable files. They have this extended Go template language that you can even use Go template in your values file. It doesn't create a state file on its own, so it's really setting apart from the Helm release. So if you use the command Helmfile apply, there's nothing related to Helmfile that will end up inside your cluster. What you'll have is that classical secret of Helm tree file in your, secret in your namespace. That's it. It doesn't create a state on its own. You have a good separation of logic and values. You have multiple ways to reference values and charts and so on. It can transform almost everything in a Helm release. If you have just a single manifest and you execute this single manifest with Helmfile, the end result will be a Helm release installed in your cluster. And you can define dependencies between your releases inside the same file. There are many other characteristics. If you don't know the tool, please take a look. It's very, very nice tool. So this is, like I said, this is the little bit of code that I had to put on the slide. So this is a classical and most simple Helm file. We have this section here, the repositories one, and the releases. There are other sections I will talk later. But what you're basically doing here is you're defining a repository called BigTummy and using this URL to use it. And at this second session, in the release section, you're saying, hey, I'm going to install the package called external DNS using the shard here from the repository BigTummy and this version, and here are the files. Two nice things to point out here is if you see, I'm using the Git URL. I mean, you can reference branches, tags, and so on. And you can, like I said, use values in your, Go template in your values files. Okay, there is another very nice feature. Like I said, Helm files are composable. There is this session called Helm files. So a Helm file can point it out to another Helm file. So this is one of the core features that we rely on in order to create our distribution. So if you take a look here, what we are doing is that we are using those entrances here to say, hey, I'm pointing to another Helm file, and I'm using those values to set, for example, to make a modification in this Helm file. I'm going to show you how we pass these values between Helm files, but this is basically the feature that we rely on to create our distribution. So we can point Helm files with Helm files. What if the second Helm file is actually another Helm file? Well, that does works. That's why our distribution is based on Helm files everywhere. So this is the basically schematics of how we do it. So we have a Helm file that defines our cluster. Our cluster Helm file will point to say, hey, I'm using this Helm file as a distribution using the Helm file session. This Helm file distribution is actually pointing to Helm files that are the definition of package installing. So by using those chains of Helm files, we can achieve a lot. I'm going to go through those files, very simple files, just to get the concept, and I hope it becomes more concrete for you. So this is our cluster Helm file. It's like I said, this is of course a very simple code that okay. So this defines our sales cluster. It's a Helm file that will point to the distribution file. And I'm telling here, hey, I'm going to pass some values. For example, the package parameters, I'm passing a value enable equals false. There's another very nice characteristic here that, like I said, they are composable. You may rely on that or not, but here we are pointing out to our distribution Helm file, okay? And here we are pointing out to our set manager package Helm file. Why is that? because sometimes you want to install another tool, and you don't want to do this reference inside your distribution. Just like I mentioned that you can install a specific Debian setup in a server, and then you can download a third-party Deb file and install it, or point to another repo and install, not based on your main distribution. So this is the kind of flexibility that we have with this model. Okay, so we are pointing out to this distribution file, which is a Helm file. So let me show this Helm file. It's another very simple Helm file that points to packages. Okay, so this Helm file is actually saying, hey, I want to install the Grafana package in the Prometheus package. But these are not Helm definition. Those are also Helm file packages, and I will show you in the next slide. But here are where things got interesting. Remember when I said that our distribution needs to provide the default values that we understand as an infrastructure team, we define as these, those are the values that we need to put here in order to make the cluster production ready. This is one of the layers that you can point it out to define your values. Another thing to, if you look here, is how I can read from the previous files those values and put them in here. So if you look at here, you see that I'm disabling Prometheus, right? So we are now looking to this distribution file, and what we are saying here is, hey, get the values from the previous file, specifically the Prometheus dictionary that is defined there, and glue it, paste it here. So this is how we create this chain that will take the values from the first file that is defined to the last file. And what is the last file? I'm going to show you the Prometheus file. So this looks actually much more simple than the other ones, but this is the first, just like the first one that I showed you. It has the repository. We are using the upstream Helm chart from the community, and we want to install the Prometheus. And look at here, we have a condition. We will only install this package if this condition is satisfied. And there we said, hey, disable Prometheus. So this will not install this package. But I needed to show you how we had to do, how we do this chain of values. This is also declaring that the Prometheus release will actually depend on the Prometheus operator to be installed first. This is another nice feature that we can do here. And of course, last, we have that same Go template code over here that says, hey, I'm going to grab the Prometheus dictionary from the previous files again, and I'm going to glue the result here. So if you think about all the change that we are doing here, all the change that we are doing here, we are defined on the first file that we will disable the Prometheus, and I could, of course, make it enable, and I want to provide more memory for it. So this is how we pass the values through. Okay, so if we want to put it all together, that's how we do it. We have a CI/CD pipeline based on GitLab to do this. All of our code is committed to Git. We have a lot of Helm files and Helm charts. So I'm going to show you how a cluster workflow will work with this distribution. So if we have an operator and she wants to, for example, change value for memory in Prometheus, what you had to do is do a commit and open a PR to this cluster over here. And this will trigger our CI/CD, our automation, and the process will actually execute a file on this context, using this Kubernetes context from this file, and we'll execute a command called Helmfile diff that will basically point it out to you, hey, that's what you are changing by doing this. So if you accept this change, the CI/CD will actually commit, apply, and merge the branch, and you have a new release installed in your cluster. You can think now as you can make modifications in your distribution level remember that we are talking about levels of Helm files. And if you want to change, for example, hey, I want to define a new distribution value, custom value, you do the same process. You do a commit, open a merge request, and the CI, and then you run our automation process. This is important to understand. When you run this, you always using the command Helmfile pointing to the cluster Helmfile, right? Because it's incomplete for you to run in a specific context, run inside the distribution. Remember that we have a lot of values defined in other places. So this is very important to understand. The pipelines here, even though you committed a modification in our distribution file, will be executed in the cluster files. This cluster over here is the only one that uses the distribution branch or tag edge. So that's why it's only this cluster that is receiving the new value. Okay, I'm trying to mix the workflows over here to make you understand the whole possibilities that we have. And of course, we have the package workflow, which is how you change the last piece of Helm files with our packages. So for example, if you want to say, oh, my Prometheus packages now uses the version 2.38, you can do this, you can make a PR and so on. And after that, you can tag, for example, your Git repository with the tag 1.1.3. You go to the distribution and say, hey, my distribution will now use the package, the Prometheus package using the tag 1.1.3. And I will also tag, you may or may not do this. This is Git flow, you do whatever the way you want. And I'm going to tag my distribution with the 2.0.1 version. And I'm going to say that, hey, this cluster actually now uses the last version of my distribution. And of course, we will apply. It is very important to know that we are running this kind of model for more than 3 years. So we have experimented with a lot of Git repos organization. This is very this last workflow that I'm showing you is very bureaucratic. You have to open a lot of PRs and so on. So we tried this for a while, but it ended up making it much more simple. And this is how our organization works today. So we have just one single repository with the cluster definitions. Each folder has the definition of business unit. They have their cluster Helm file that points to the same repo. So we don't have tags for distribution anymore. We don't have versions of distribution. We're all in using head, okay? And the distribution actually is a Helm file, like I said, that is consuming Helm files inside those folders. Each one of those folders, like you see, oh, the security team used this folder, and the layer 7 team, and the database team, they all have their own packages, versions, and so on, and they are, of course, pointed out to the Helm file definitions of their packages with their default values. So how about tests? If you really want to say that, oh, your distribution is just using Helmfile to install Helm packages, right? It's, of course, it install, upgrades, and reconcile, but that's all. We are installing. The really core problem here is how we do governance on our Helm packages. So I could talk for half an hour about this process. It's only this slide because it's a very complex but very complete process of how we handle our Helm packages. But basically we have one repo per package with a lot of governance. I mean, they are divided by impact level. We use vCluster. I don't know, does anybody here know vClusters? vCluster is a way that you can run Kubernetes clusters inside Kubernetes clusters. It's not that beautiful, but this is a way that after, for example, upgrading a package, we wanted to be sure that this package will now work in our Kubernetes supported versions, which are now 3. So we use Pluto as a software to check for API deprecations. So if our package is actually using something that is deprecated, it will give us a warning. We use TerraTest to create unit tests for our Helm packages. A lot of Golang to create integration tests. So if I wanted to install Prometheus, I have to create code that will actually see if it's really running, if it's providing the functionality and so on. And a lot of, like, we use Renovate bot and semantic release and so on. So like I said, this is a very long topic. I could talk for half an hour just on that. Our conclusions, well, we have the good, the bad, and the ugly. The good, our distribution is really 100% based on Helmfile. It is flexible, like I showed you. It is scalable. Like I said, we are running from more than 53 clusters. It is extensible and standardized. Like I said, we have other business units creating their own Helmfile packages, and the concept is modular and reusable. What I mean by that is, since Helmfile doesn't have any participation in the end result of the installation of a package, we can remove and throw Helmfile away, and nothing will change in our stack. Everything will keep running. What are the bad and the ugly part? The dependency check between split Helm files, just the way that I showed you, doesn't work very well. We have to code a specific routine to identify if you have a dependency. So, but this is not native. We have to code this. Is it simple? Well, depends. After you get used to it, it gets simple. However, it might be hard to understand where a value came from. Like I said, you can define values coming from your cluster Helm file, your distribution, your package. So if you see that someone put 1,400 gigabytes of memory into an application and say, where did this come from? So it's kind of hard to track. And another thing that we solved recently is it could be a parallelism, a low parallelism, depending on the way that you create your repo in your distribution organization. Basically because Helm files apply the Helm charts in the positional sequence. So you can overcome that with flags, but if you don't say not for, if you use it at standard, it will apply from top to bottom. So that we have more than 40 packages to install and maintain. So can you imagine if I do like, oh, I need just 1 gigabyte, extra gigabyte in my Prometheus setup, and I have to run a pipeline that will try to see if there is any difference in any other packages. So we created something that could identify just the type of modification that we were doing and apply just this, and that became very, very nice for us. Like I said, there's a lot of reference. I probably explode the time, right? So a lot. I'm so sorry. I'm terrible at time management. Thank you, and you can find me over here. So thank you very much.
So again, we have time for questions.
Really? Oh, nice. Okay.
So after running Kubernetes for at least 6 years, I think I got it.
Yes.
At that scale, and even going to the point of running Kubernetes, a Kubernetes cluster inside a Kubernetes cluster. My question is, how do you still have all your hair? Are you wearing a wig?
This is an amazing question. Really. Because I had hair transplant a few years ago, so this is true. So you're right that this is too much, but mostly because of the scale. I think you only have to. I mean, this is all modular concept. You can use if you want, if you have just one cluster, if you want, of course. However, this is done by scale because of our scale. So it is hard. I know.
Okay, so a more appropriate question. How do you debug your Helm files? You mentioned that tracking the values is difficult. Do you have any-
Well, tracking values is still difficult. There is no way, there is no easy way to understand this. Of course, since everything is on Git, we can track the commit or use a Git blame, so on and so forth, and say, oh, so it was you. But tracking the values are still very hard for us. But it was not the hardest part for us. The lack of parallelism was the biggest one, and we solved it like 6 to 8 months ago. Like I said, this is a very long project, very long project. We've been running like this and changing the way that we define our distribution and the organization of our Helm files and so on. So it is hard, still hard to detect files.
Wait, you weren't kidding with the airplanes, friends?
No, not at all. You see? Oh no, this is not this is new. But the photo that was shown before, I had almost no hair.
Makes sense.
Hi, Daniel. I want to thank you for the talk. It's really great. I've got a couple of questions. Where are you running K8s? Are you running it on a cloud provider?
Yeah, AWS.
AWS, so you're running it on
Yeah.
EC2?
Yeah, we manage our own 53 plus clusters.
Okay, so you would have to then create the EC2 server, and then you would run your Helmfile from that server if you want to create a new cluster.
Yes, precisely. Yeah, we have, of course, everything automated. If you want to create a new cluster, everything is coded in code, and there's a lot of Terraform and GitLab pipelines involved. But you can provision a K8s cluster, with all of our sets really quick.
Yeah.
Actually, and after doing this, you just create a new folder in our Git repo saying, hey, there's now a new cluster with this variables and this kind of values that I want, and you can apply it to run.
Yeah, I was going to ask which infrastructure as code tool you were using, because it's very interesting. I personally use a Terraform approach. I use Helm with Terraform, and I can kind of create my distributions that way. But as you were speaking, I was like, how do you push a change downstream from your distributions? But I think you solve that by having a monorepo, and then you can see the changes there.
Yeah, well, like I said, we tried a lot of ways to manage our repo, specifically the distribution repo. It was very bureaucratic process to change the package and change the
Because you have to run your pipeline.
Yeah, so the last slide is actually our current infrastructure. So if you do modification in the distribution level, it's already applied to every single cluster that is using the head distribution. Actually, there is no more tags for distribution, so it's always on the head.
Perfect. When you said monorepo, I said it's probably because of the distribution.
Yeah, it was insane to try the first model.
Sure. Did you guys look at crossplane?
But I think there is other. It's not the same objective there, but yes, we don't use crossplane. We use Terraform, TerraGrunt, and a whole bunch of other HashiCorp stacks, but just for provision AWS, not to provision nothing inside Kubernetes.
Okay, perfect. Thank you.
You're welcome.
So one last question.
Hello, I'm just wondering, have you considered using something like customize instead of Helmfile? Because from my small experience, Helmfile seems to be a bit more complex than customize. And just a curiosity, why do you need 53 Kubernetes clusters?
Yeah, we get that a lot. I get a lot of this question. So customize, like I said, Helmfile is so flexible that you can use to point to a customized file. And the end result, like I said, will be a Helm chart. Basically, it will convert on the fly to to a Helm release, and it will install in your cluster. So we do have a lot of customized code inside of our repos, because for most very simplistic things or more straight way that we want to install something, we could, like I said, put a raw manifest or a customized, because it's very simple, like you said. But the end result will be a Helm shard installed there. So that's basically why we want it to be 100% compatible with Helm. Not, like, for example, doing a kubectl applied minus .f and so on. 53 clusters, why? We have a lot of business unities, and there's this mentality of isolation. I mean, so there is no way someone from logistics to talk with or to deploy or to blast radios. I mean, if you break something in logistics in terms of infrastructure, it will not, get into the marketing cluster or something like that. It's more because of isolation. It's almost a one-by-one reflex over our cloud model. So that's basically why. But we do, like I said, have more than 3,000 microservices, and we are a food tech company. We have, of course, the lunch time and the dinner time, a gigantic workflow of many requests. So it's good to have smaller clusters instead of a few gigantic clusters to manage. Like I said, it's less blast radios and so on. So this is basically why it's more of a business and reliability decision than anything else.
Okay. Thank you very much. Again, let's talk after. Thank you very much, Jan.
Thank you.
So first, we're gonna do the raffle. Does everyone has a small paper like this? Don't?